And welcome to our talk from zero to scalable, accelerated on-premise infrastructure with Omni and GitOps. Let's quickly introduce ourselves. I'm Alexandre Ferreira, SRE and Devops engineer at Promptly Health.
So I'm Paulo, SRE DevOps engineer at Promptly too.
You've probably never heard of Promptly, but we are a company helping healthcare institutions, mainly hospitals across Europe, taking advantage of their data. This is a very summed up description of what we do, but you can visit us on LinkedIn and find more about us. Also, we are both from Portugal, as well as the company was born in Portugal. Who's here has been to Portugal already? Oh, some people, after half of the room. So for those who haven't, you might know it as the home of the greatest footballer of all times, Cristiano Ronaldo. We had to do this, okay? No, Messi, no. It's in the law that we need to talk about Cristiano Ronaldo every time we go abroad. So let's talk a little bit how we got here, and then in the end we'll demonstrate how we deployed 50 clusters in less than 7 minutes with Omni and Talos. So about 1 year ago or so, our company challenged us to build a pretty straightforward product, build a federated health data network spread across different regions. Pretty specific, right? Well, fortunately we had some requirements. It should be infrastructure agnostic, so that it runs on any of the infrastructure the client already has. It should be, the data should not leave the premises of the client. It should be isolated. It should scale to hundreds of clusters. It should be secure by design, portable, for example, using Kubernetes, and deployed in the uniform way across environments. And since we are here today at TalosCon, it's pretty obvious the solution that we went for. It was Sidero, Omni, and Talos Linux. So I don't know if everybody here has used Omni. I'm assuming everybody here knows Talos and their functionalities. Some of them we can do the parallel with Omni, but we've summed up some of the more important for us functionalities. It has built-in image factory, a WireGuard link to each node, automatic control plane backups, full cluster lifecycle management from the cluster creation, deletion, scaling, downscaling, upgrades, etc. And also important, it has cluster templates or cluster as code. We have here a snippet of the manifest of the cluster. We can define the Kubernetes version, the Talos version, the features that we want enabled on Omni, and also patches for the cluster or sometimes for the control plane, workers, or dedicated machines. Here we have an example of the Cilium CNI that we enable the Cilium CNI that disables a default that is flannel. We also have an example of enabling the audit logging in the Kubernetes, in the cluster, in the Talos cluster. And then we can define which machines belong to the control plane or which machines belong to the worker nodes. There are more attributes and more stuff we can do with the cluster templates, but it's just an example. So we've talked a little bit. The solution is composed of Talos as the Kubernetes distribution, Omni to manage the clusters, but how do we approach the day-to-day operations like application deployments? So for this, and like many of the enterprises nowadays, use a GitOps model using Argo CD. Actually, we use an hub-spoke model for Argo CD, where we have a central Argo CD that connects to Omni, and Omni then proxies all the requests to the desired clusters through the Kubernetes API proxy. So this has been a capable solution, which has allowed us to centralize all the applications deployments through many clusters in one central place, that is Argo in this case. Because we are a small company, it would be hard to manage multiple Argo CDs across different clusters. But obviously this architecture has drawbacks. For example, the application controller needs some fine-tuning because it's a stateful set and needs to reconcile many applications across many clusters. And also the hub-spoke model is not the most secure model, to be honest. But it has allowed us to scale, which right now it's the most important for us. So, talking a little bit about one problem that we had when we tried to connect a central Argo CD to Omni. So, normally when we try to add a cluster to Argo CD, we need to first create a kubeconfig service account in Omni. And if we do this multiple times, you'll know that the same cluster or the server URL will be the same for all the kubeconfigs. It will be, for example, demo.kubernetes.omni.io. And in Argo CD, it will show something like that. We have the cluster 1, demo 1, and the server URL. It's demo.kubernetes.omni.io. And the same for the 3 clusters. I mean, this shouldn't be a problem, right? Since we have different cluster names. Well, actually, not quite. When we first tried this, we were actually trying to apply an application in, for example, the cluster demo 2, but we couldn't find the application in the cluster, believe me. And the application was actually being deployed in the cluster demo 1 because Argo CD internally uses the server URL as kind of a key. So it will always use the first cluster that was added, and it will always deploy the applications in the first cluster because the server URL is the same. So how have we managed to solve this if we went with a central Argo CD? We tried using the NESC names and change the configuration of core DNS, but we found a much simpler solution in our minds. It was add a query parameter to the server URL. So it will, in Argo CD, the keys or the server URL will be different since the string is different. And when we connect to the Kubernetes API via the Kubernetes proxy, it will just use the demo.kubernetes.omni.io. So in the end, everything works out. We will have the demo.kubernetes.omni.io !, and the ID, and you use the cluster name because ideally all the clusters are different, right? And this way we can manage multiple clusters, multiple applications in a central Argo CD. So moving forward, we talked about the components separately, but how does everything comes together? So we made these representations more like a timeline of the entire process when we try to deploy a cluster in one of our clients. We first start with the creation of the Talos image. This is pretty straightforward in Omni. We just need to select it if it's VMware, AWS, Azure, etc. Then the client needs to boot the image. And if everything works out, mainly if the network part is according to the requirements, the machine will appear on Omni, and we will be able to go to the next step, that is the cluster creation. We normally define the cluster template, define the patches that we need, the pull-through cache, CNI, etc. And then when the cluster is created, I mean the control plane is ready, the worker nodes are ready, the Kubernetes API is available, we can go to the next step, that is creating the kubeconfig service account. And with the kubeconfig service account, we have the beer token, we can associate the cluster in Argo CD and start deploying the applications for the project. So these are quite repetitive tasks, yeah, if you ask me. I mean, from the cluster creation, or I mean the cluster templates forward, it's all the same to different clients. I mean, sometimes the patches are different because we have to define disk selections, etc., or pull-through cache configuration, different pull-through cache configurations. But other than this, it's all the same process. So we've decided to automate part of this. Omni and the cluster templates, it's actually very good. We can define all the cluster as code, but it's hard to scale by itself. It's error-prone, and there are a lot of repetitive tasks. So we've decided to use the available Omni client SDK and Argo CD client SDK to automate this entire process. We have here an example of the Omni client SDK, where we list all the machines and their connected status. You can see more on the link down below and a full spec of the Omni API, the Go Omni API. So let's jump to the demo.
So now, just to show, we have prepared a pre-recorded demonstration that will allow us to visualize what Alexandre explained before. So for this demo environment, we have created an Omni self-hosted environment and an Argo CD instance in order to set up everything. We already have 100 machines connected to, oh yeah, it's playing. 100 machines connected to our Omni server. As you can see, any cluster have been created yet. And if we move to the machines view, we can see also that, I lost it, okay, yeah. You can see also that some more metadata information related to these machines. For the simplicity of this demonstration, we set up all machines with the same metadata information. So the instance type is the same, the Talos version is the same, the resources deployed are the same. Moving now for what is needed for our automation to run. Lost my mouse. Oh yeah, it's ready. So we need to, for our automation to run correctly, you are seeing no clusters, none of them have been created. We'll do it later. So moving for the settings part, we have set up a service account that will enable us our automation to interact with the Omni server and create the necessary clusters. Moving for another piece of our demo, here you can see the Argo CD instance. We have none application deployed yet. Same goes for the clusters connected. Yeah, we don't have any. Let me just show. Oh, sorry. We don't have any cluster deployed yet or connected yet. So we need to, as we do the same for the Omni server, we created a service account for this Argo CD instance to be able to connect all created clusters. So moving now for the hands-on part. Let me just show you. Yeah. Oh, it's closed now. Sorry. Yeah. Now, here you can see a YAML manifest. This is a definition of an application set. As you can see, or more, I believe that you already have in touch with Argo CD, but if you don't know, an application set is something that enables you to add multiple applications or deploy multiple applications to different clusters and to add more flexibility in the definition of your applications. Here we have deployed an Nginx application using the open source Helm chart. And for this highlighted part, we have the generators type that we define these clusters. As the name implies, we are deploying for each connected cluster in the Argo CD application or the Argo CD instance, we are deploying an Nginx application. Moving forward, another important part is the sync policy. We have the automated part, so every time that a cluster is connected to the Argo CD instance, the application is automatically created and every component is deployed without any manual intervention. Now, running our script or our automation, we are now connecting to the Omni endpoint and starting by grouping all of those 100 machines in pairs, one for the control plane and another for the worker node, just for simplicity. And our automation is just waiting for the clusters to become healthy. So we are waiting on the control plane to be healthy and for the Kubernetes API to be available. So as you can see, we have already on the Omni 50 clusters created. None of them are healthy. So we are just waiting a little bit for everything. For the machines, you can check that all the 100 machines are connected to each of the 50 existing clusters. So move forward. Yeah, as you can see, we already have a connected, created cluster and already healthy. That is the demo 28. If we move now for the Argo CD application, we can see this application already connected. This is the Nginx application that we already defined in the application set earlier. So as more and more clusters are added to created on the Omni server and added to this Argo CD instance. We can see the progress of these pie charts for the sync status and the delf status, as they will progress from the .off sync status as the clusters are added, and to the synced status, and again for the delf part missing status from the progressing part, and for the final elf status. So we can see this progress also in the Omni page. As you can see, we have now 8 elfy clusters, but you're gonna accelerate this one just to fast forward just to check that everything goes as according to the plan and be deployed the 50 clusters and the 50 Nginx applications. So let's just wait a little bit. Yeah. Yeah, there you go. 50 clusters already deployed, already elfy. So we can go for another important part of this demonstration. Here, now another part there that Alexandre was explaining earlier is the day 2 operations. That is like we deployed the whole clusters, but we need to manage these clusters after the first deployment. So we kind of need to have this definition of this manifest of what are the control plane nodes and the worker nodes and the cluster specification. We need to operate it on a day 2. So if we want to update the version independently from the other clusters, we need to be able to do that. So for each cluster created by our automation, we create also this manifest with all the information for the deployed cluster. So let's just check. Yeah, okay. Now on the application, on the Argo CD applications view, we can see that, for example, this demo one Nginx application means that this is the Nginx application deployed on the cluster demo1. So we can see that every component is deployed as specified in the Helm chart. As if we go to the container logs, you can see that the application is behaving as expected. So I can move a little bit forward in this part. So another important part for the hands-on, we probably want to connect to these created clusters. We can do that by just downloading the kubeconfig on the Omni server. We can do another operations like download Talos config or do cluster scaling or update Kubernetes version or Talos version. But for the scope of this connection to the cluster, we just need to download kube configuration file. We are now doing the definition of the environment variable for the kube configuration file. As for the Kubernetes tools like kubectl knows where is located the kube config file and can connect and interact to the correct cluster. So now we'll try to list the pods existent for the Nginx application in this cluster. As you can see, we are redirected for the Omni server, and if we grant the necessary access, we can list the existing pods for this application. Now doing a port forward in order to connect this Nginx server, we'll just connect and see everything on our local machine. So you'll be prompted with the Nginx servers page. And yeah, that's everything for the demo. Let's move back to the slides.
Yeah, one thing that I forgot to say previously, when we create the kubeconfig service account, it gives us a beer token. It's different from the authentication that we saw here in connecting with the kubeconfig. It opens the Omni via OIDC and connects to a temporary token, connects to Omni successfully. And with the kubeconfig service account, it bypasses that part, creating a beer token just to authenticate in the Kubernetes API of the cluster. So the demo is finalized. We managed to create 50 clusters in less than 7 minutes. Actually, the first cluster was ready about 3 minutes, and the other ones took a little bit longer. Around the 5-minute mark, all the clusters were already ready. Yeah, the rest of the time was just deploying the applications in Argo CD. We can easily scale this to 100 clusters, 200 clusters. Omni is more than capable of that. So going further, we will integrate this with Arbor for the pull-through cache configuration. Actually, we already did this. Believe me, when we tried to deploy 50 clusters and pull the Docker images via only one NAT gateway, you will reach the pull-through, the pull rate limits. So we had to deploy Arbor to act as pull-through cache here. We'll also integrate the Cilium CNI. When we patch the cluster for the Cilium CNI, we are just disabling funnel. And we need to deploy the Cilium operator for it to work. So we will integrate this as well. And I don't know if anyone has felt this, but when we look at the cluster template, it kind of resembles of Kubernetes manifest, right? So it makes sense to create a custom controller, Kubernetes controller, and a CRD with, obviously, with some custom configurations for our use case. And yeah, who knows, an Omni crossplane provider. Crossplane is on the rise, so yeah, that's it. If anyone has any questions, feel free.